Good morning, everyone. In this video, we will discuss an ellipse with center at 0, 0. So we have here an ellipse with foci that lies on the x-axis and ellipse with foci that lies on the y-axis. So for the x-axis or ellipse with foci on the x-axis, we have the equation x squared over a squared plus y squared over b squared equals 1, where c is equal to the square root of a squared minus b squared, and a is always greater than b. And for the vertices of this ellipse, we have the quantity of positive and negative a, comma 0. For the foci, we have positive and negative c, comma 0. And for the equation of the major axis, y is equal to 0, location on the x-axis, length 2a, endpoints positive and negative a, comma 0. Minor axis, the equation would be x is equal to 0. The location, it is on the y-axis. The length is equal to 2 times b. The endpoints, we have 0, negative, and positive b. And for the x-intercept, positive and negative a, y-intercept, positive and negative b. For the directrices, we have x is equal to positive and negative a squared over c. For the latus rectum, the equation would be x is equal to positive and negative c. Direction is vertical. Length is equal to 2b squared. So for the length, we have 2b squared over a. And for the endpoints of the latus rectum, we have the quantity of negative c, comma, positive and negative b squared over a. And the other endpoint is positive c, comma, positive and negative b squared over a. And permissible values, we have it here. And next, for the ellipse with foci on the y-axis, we have the equation x squared over b squared plus y squared over a squared equals 1, where c is equal to the square root of a squared minus b squared, and a is greater than b. For the foci, or vertices rather, we have the quantity of a plus or positive and negative a, foci 0, positive and negative c. And for the major axis, we have the equation x is equal to 0, location on the y-axis, length 2a, endpoints, quantity of 0, comma, positive and negative a. For the minor axis, the equation y is equal to 0, the location on the x-axis, the line 2b, endpoints, positive and negative b, comma 0. And for the x-intercepts, we have positive and negative b. For the y-intercepts, positive and negative a. For the directrices, y is equal to positive and negative b squared over c. However, sometimes, in some scenario or cases, instead of using this formula for the directrices of this type of equation, we can also make use of this, because sometimes in this case, it will give you a values of y which is much lesser than the points of the focus or the vertices. So we can also make use of this value or formula for the equation of the directrices or the values of the directrices. Next, for the equation, we have equation of the latus rectum, y is equal to positive and negative c, direction horizontal, length 2b squared over a. And for the endpoints, we have the quantity of the positive and negative b squared over a, comma, negative c. And the other one, the quantity of positive and negative b squared over a, comma, positive c. And for the permissible values, we have it here. So I will present to you or give you later some example about the problem involving ellipse with center at 0, 0. So for example, we need to find the coordinates of the foci in the vertices, the endpoints of the major axis, the minor axis, and the latus rectum of each ellipse, whose center is at the origin or 0, 0. And we need to draw the ellipse its foci and its directrices. But for us to draw these points or concepts, we need to find it out first. Okay, for example, number one, we have y squared over 36 plus x squared over 20 equals 1. So since we have this equation, y squared over 36 plus x squared over 20 is equal to 0, we will try to find it out or determine whether what type of ellipse do we have. Does it have foci that lies on the x-axis or foci that lies on the y-axis? So here we have ellipse that lies on the ellipse with foci that lies on the y-axis. So therefore, we have this equation here or formula maybe. So we have y squared over a squared plus x squared over b squared, or you can write this and this way. We have x squared over b squared plus y squared over a squared equals 1. So we have it here. We write this in this format. The square of our denominator is here. We have 6 raised to 2 and 2 square root of 5 raised to 2. How do we arrive in this process or on this form? So we need to identify first the values of our a squared and b squared. Take note, class, that a is always greater than b. So it follows that 36 is the value of our a and 20 is the value of our b. Or 36 is the value of our a squared and 20 is the value of our b squared. So we have it here, a squared is equal to 36, b squared is equal to 20. So for us to find the values of a, b, and c, we will try to do this using the we will try to solve this using the extracting the square root method. So we have a squared is equal to 36. So in order for us to find the value, for the value of a, we will eliminate this square here by extracting square roots. So we enclose both sides of the equation by square root radical sign. So we have square root of a squared. We will now cancel this out. So what will be left is a, and square root of 36 is 6. And next for b, we have square root of b squared equals 20. Since 20 is not a perfect square number, we will try to find a factor that is a perfect square number, and we will try to simplify this out. So since we have factors of 20 that is equal to 5 and 4, or 4 times 5, 4 is a perfect square number and 5 is a prime number. So therefore, we have square root of 4 times 5, and we can simplify square root of 4, that is 2, and what will be left inside the radical symbol with index 2 is 5, because 5 cannot be simplified. So the value of b is 2 square root of 5. Therefore, b squared looks like this and a squared looks like this. We will just square the values of a and the values of our b. And next, since we have now the values of our a and b, we will find now the value of our c using the formula square root of a squared minus b squared. So we have it here, 36 minus 20. So square root of 36 minus 20 is equal to 16. So square root of 16 is 4. So c is equal to 4. Since we have this form of equation of ellipse with center at 0, 0, it follows that these are the characteristics or the format of our foci, vertices, major axis, minor axis, endpoints of our latus rectum, and directrices. So first, we will try to find out the endpoints of our focus or foci. So the foci of this ellipse is on the form quantity of 0 or quantity 0, comma, positive and negative c. Whatever will be the value of your c, that will be substituted here. So in our case, in this example number 1, c is equal to 4. So we will just substitute it here. Actually, we have positive and negative because this refers to 2 points. We have 2 focus. So kaya tinawag siyang foci. So it could be written also in this way: 0, comma, positive c, and the next ordered pair, 0, comma, negative c. Or you can write it in this way. So when substituting the value of c, we will just plug it here and copy the sign, whatever sign we have here. So we have positive and negative. So, and we have here 4. So we have positive, negative 4 here. So the points of your foci is on the point 0, comma 4, and 0, comma, negative 4, or 0, comma, positive and negative 4. Next, for the vertices, it is in the form 0, comma, positive and negative a, or ganito. Okay, the question is, where did we get this format? Where did we get this formats? We get this format, or we take this format from the table I shown you a while ago on the summary of the characteristics of ellipse with center at 0, 0. So you need to be familiar of it, and for you to be equipped with it, so you should read and read for you to memorize the concepts or even familiarize it. So next, since we have the format of vertices and the point 0, positive and negative, comma, positive and negative a, so we will just substitute the value of a, which is 6. So we have it here, positive and negative 6. Next, for the major axis, we have 0, positive and negative a. Same with vertices. So we have here 0, positive and negative 6. Next, for the minor axis, we have the endpoint positive and negative b, comma, 0. So for the value of b, we have 2 square root of 5. So we have it here, positive and negative 2 square root of 5, comma, 0. And for the latus rectum, we have this ordered pair here. We have these ordered pairs here. So we have positive and negative b squared over a, comma, negative c. And the next ordered pair, positive and negative b squared over a, comma, c. So we will just plug in those values. If the fraction that you formed is not divisible or improper, just write it as an improper fraction. Don't dare to transform it into a decimal number or mixed fraction. Just like, for example, here, so we have positive and negative. B squared is what? What is b squared? Why do we have 10? Okay, so why do we arrive on these endpoints of our latus rectum when we have this format here? All we need to do is just substitute the given values or the values that we have found out a while ago into the format of the endpoints of the latus rectum. So I will show you the process. So we have it here. Since the format says that the other endpoint of your latus rectum is on the point positive and negative b squared over a, it says here that b is equal to 2 square root of 5. So in this process I shown you, I take part of the value of b, which is 2 square root of 5. So we have and also we have the exponent too. So we will just substitute the value of b, and we will square it, and we will distribute the exponents to 2 here and for the 5 here. So 2 raised to 2 is 4, and square root of 5 raised to 2, we will cancel the square as the exponent and the square root symbol here. So what will be left is 5. So 4 times 5 is 20, and we will simplify 20 over 6 because 20 over 6 has common factor, which is 2. So 20 divided by 2 is 10, and 6 divided by 2 is 3. Or let's say, if you don't want to include this process here above, you can directly go into this process. Since we have here b squared, and you already know a while ago that b squared is equal to 20, you can directly input or plug in b squared that is equal to 20, which is here. So positive and negative 20 over 6, we have the common factor, which is 2, and we will divide the common factor into our numerator and denominator in order for us to get the simplified format, which is 10 over 3. So we have the first ordered pair, and same as true on the other side. So we have here the partner is negative 4 and here is positive 4. Okay, so since you already know the process, we will try to graph this. Okay, but before anything else, before I forget, I will show you the process on how to find the directress or directresses. So in the equation or in the summary of the characteristics of ellipse with center at 0, 0, if your ellipse has foci that lies on the y-axis, it tells you that the formula of the directresses is equal to y squared equals positive and negative b squared over c. So for your benefit, I shown you the process. So we have it here, b squared is equal to 20, c is equal to 4, so 20 divided by 4 is 5. But later, if you're going to graph this, it is not located outside the graph of the ellipse. However, it is located inside the graph of the ellipse. So we cannot apply this formula. Instead, we will adapt the formula of the other ellipse, which is the ellipse with vertex or with foci that lies on the x-axis, which has the formula. Where's the formula of the ellipse? So here is the formula. So we have y is equal to positive and negative a squared over c. Actually, in the table, we have here x that is equal to positive a squared over c. So for us to have the value of our directrix or directresses, we will just substitute y here in our x. Instead of using x, we will write here y. So we have it here, positive and negative a squared over c. So a squared is equal to 36, c is equal to 4, so we have 9. So my tip is, before you solve for the directrix or directresses, try to plot first your ellipse, your foci, vertices, major axis, minor axis, and your latus rectum. And from there, you will identify if using the value of the ellipse or directresses here will give you a correct answer, or will you adopt the other way of solving the directresses of your ellipse. It's up to you. But my technique here is you will plot first the graph before determining the value of your directresses. So for the graph, we have it here. And as you can see, we have here the estimated value of positive and negative 2 square root of 5, which is equal to the positive and negative 4.47. And for the positive and negative 10 square over 3 is equal to the positive and negative 3.33. This is just for the benefit of the graph on plotting the points for us to determine the estimated position of the points in our Cartesian coordinate system. So for the center, we have the origin, and for the foci, we have the point. We have 2 points here. Remember, we have 2 points. The first point is 0, comma, positive 4. And the next one is 0, comma, negative 4. And next is for the vertices. We have also 2 points here. 0, comma, positive 6. 0, comma, negative 6. And for the major axis also, our major axis is equal to our vertices. So, and the minor axis is the other way around of endpoint of our axis. So we have the minor one and the major one. So the major is equal to the vertices, and the minor one is at the side. So we have uh, positive and negative 2 square root of 5. As what I have told you a while ago, the estimated value of it is 4.47. So we have here, take note, in estimating value and plotting of points, you need to be precise, or at least it is realistic. But because in some other graphs, 4.4, they plot the graph of 4.47 here, or almost close to 5, which is not really correct. So here we should estimate it correctly. So we have 4.47 and 0, so the intersection of 0 and 4.47, or negative 4.47, and the other one is positive 4.47. So before connecting the dots, we should try to make sure that we plotted all the points here, but we are not yet finished in plotting the latus rectum. So we have 10.3 is equal to 3.33. So we have 2 points or 4 points here, 2 points, and 2 points here. So first we have positive 10 over 3 and negative 4. So dito siya. Positive 10 is 3.33. So we have here 3.33. Our x is 3.33. Here 3.33 and negative 4 here. So the intersection of 3.33 and negative 4. So we will trace this out, and this is the point. And the next one, negative 10 over 3, which is negative 3.33, and negative 4. So the intersection of the two values, we have it here. Next one, we have positive 3.33 and positive 4. So here, positive 3.33 and positive 4, the intersection of the two values, the point is located here. And for the negative one, we have negative 3.33 and positive 4. So we have it here. So we plotted already all the points in our Cartesian coordinate system. So we will now connect the dots that will give you an ellipse. So this is now the graph of your ellipse. And next, for the directrices, since y is equal to 9, take note, your directrices is always after the vertex, or it is always located in your major axis. If your vertices is in the y-axis, take note, this is y-axis, this is x-axis. Therefore, your directrices should also be located, or should also pass through your major axis, which is here we have y-axis. But if your ellipse goes like this, medyo pahiga siya, pahaba siya dito, so your major axis is the x-axis. Therefore, your directrices is patayo din siya vertically. Take note of that. So here we have y is equal to 9, so we have it here and here, and we will just draw the line for your directrices. However, this does not, directrices is not really required by some authors, but in here I will just show you how to solve the directrices and how to locate this into our Cartesian coordinate system. So take note of it.